Okay, here we've got an application that we can use with inverse trig functions. So we've got sine of cosine inverse of 1/3. Okay, so in the parentheses, cosine inverse of 1/3 is going to give us an angle. So we're going to have an angle, we could call that theta. All right, so if we set up a triangle with theta, okay, we know that cosine is equal to 1/3, so that's adjacent over hypotenuse. We do Pythagorean theorem and we get that this side is square root of 8. So now what our problem is, okay, cosine of inverse is theta. It's the theta that gives us 1/3. So we're taking sine of theta, and sine of theta we can read off the triangle square root of 8 over 3. Okay, let's give this one a shot now. We've got tangent of 2 sine inverse of 2/5. All right, now that 2 in there is going to complicate things because we don't just have the sine inverse, we've got 2 sine inverse. So if we call this sine inverse our theta, okay, so theta is equal to sine inverse of 2/5, then that means that sine theta is 2/5. And our original problem is equal to tangent 2 theta. And we know that 2 theta is not the same as theta, but what we have here on the left is theta. So let's set up our triangle for theta, since that's what we know. So here's theta. Sine is opposite over hypotenuse. Pythagorean theorem tells us that this is square root of 21. Okay, so we have sine of theta, but we don't have 2 theta. But we can use one of our identities, and we know that this is equal to 2 tangent theta over 1 minus tangent squared theta. And we can get tangent theta because we have our triangle. So coming back over here, we've got tangent theta is equal to opposite over adjacent, 2 over square root of 21. All right, now normally we would go ahead and rationalize that, but I'm going to hold off for just a minute because we've still got a lot of math to do, and it's actually going to make things easier if we don't just yet. Okay, so plugging that into our fraction here, we're going to have 2 times 2 over square root of 21 over 1 minus 2 over square root of 21 squared. Okay, so on top we've got 4 over square root of 21. And on bottom we've got 1 minus, the top squared is 4, the bottom squared is 21. Okay, so continuing to simplify the bottom, we're going to have, this is the same as getting a common denominator, 21 over 21. So the top is still 4 over square root of 21, and the bottom is 17 over 21. Okay, so we can change this to multiplying by the reciprocal. So we're going to have 4 over square root of 21 times 17, 21 over 17. Okay, and we see that these 21s match, okay, but one's a square root. You can think of 21 as square root of 21 times square root of 21 and cancel them that way. Or if you're not really comfortable with that, you can go ahead and now rationalize the first fraction, 4 square root of 21 over 21. Okay, so before we multiply, if you rationalize it now, it'll simplify things. The 21s can cancel, and we've got 4 square root of 21 over 17. Okay, so if you're okay rationalizing that right here and canceling out one of the square root of 21s, that's fine as well. Whichever way makes more sense to you. Okay, so there's our final answer. So again, we had to set what theta was, then we had to use an identity for 2 theta so that we could get it in terms of theta, because that's what our triangle is. It's theta, not 2 theta. Okay, so that's an example of tying in these arc functions or inverse functions into the work that we were doing before as well. Okay, now let's look at a couple more of these trig functions with the inverse functions. Now the first one, we've got sine of sine inverse of 1/2. Now, If you remember back to when you first learned about inverse functions, they should undo each other. So f of f inverse or f inverse of f, they should undo each other and cancel out basically. But the wording in there, which you probably didn't pay attention to at the time, was for all values in the domain. So we've got to be careful now about what's in the domain and what's not for each of these functions. So for example, if we have sine inverse of 1/2, okay, so sine inverse of 1/2, that's going to be pi over 6. Okay, and then sine at pi over 6 is going to be 1/2. Okay, so for that one, the sine and the sine inverse did cancel out exactly like trig functions should do. And that's because 1/2 is in the domain of sine inverse. Okay, now when we look at this, we've got cosine inverse of cosine of negative pi over 6. These are not going to cancel out because negative pi over 6 is not in the range of cosine inverse. Okay, so watch what happens. So we just have to be a little bit careful here. All right, so we've got cosine inverse. Now we know that cosine of negative pi over 6 is going to be square root of 3 over 2. And because we are in the fourth quadrant, that's going to come out positive. Now when we do cosine inverse of square root of 3 over 2, that's cosine inverse of a positive value. That's going to return a first quadrant value, because remember cosine inverse is defined 0 to pi, or we have to restrict cosine 0 to pi, so the range is only 0 to pi. So cosine inverse can only return values in the first and second quadrant. First quadrant if it's positive, second quadrant if it's negative. So if we've got cosine inverse of 3 pi over 2, that's going to give us positive pi over 6. Okay, so that's an example there of how they don't exactly cancel out. So you got to be a little bit careful about your definitions when you're working with these inverse functions. Okay, now let's try one that's similar to the ones that we did just a few minutes ago with numbers. But in this one, we're just going to get things in terms of u. So we're not given numbers, we're just given a value, a letter value. Okay, so we want to define this in terms of u alone. So we've got cosine of arcsine u. Remember, arcsine is the same as sine inverse. Okay, so arcsine of u is going to give us a theta. That's going to return an angle for us, where sine of theta is equal to u. Okay, so that's what we're going to set up here. All right, so what we're actually looking for here is cosine of theta. So let's set up a triangle and see if we can figure out what theta is. Sorry, not theta, cosine of theta. Okay, so here's theta. What else do we know? We know that sine of theta is equal to u. That's the same as u over 1. And we also know that sine is opposite over hypotenuse. So opposite over hypotenuse. Okay, so now we do Pythagorean theorem. This is the missing side. We can call it whatever. Let's say v. So we've got u squared plus v squared equals 1 squared, and we're looking for v. So we subtract u squared from each side. And we take the square root. Okay, so we get that v is equal to plus or minus 1 minus u squared. Okay, so now what are we actually looking for? We're actually looking for cosine of theta. We're looking for cosine of theta. Okay, and remember that arcsine is going to return a theta that is between negative pi over 2 to pi over 2. Okay, that's the definition of arcsine. So the theta has to be either fourth quadrant or first quadrant, which means our cosine is going to have to be positive. And we're going to have 1 minus u squared over 1, adjacent over hypotenuse, or just 1 minus u squared. Okay, so we took this trig expression here and we got it into terms of just u by using our triangles.